about it has explanations explaining different pieces related to knowledge management, semantic engineering. It has tutorials that explain how to use Protege and how to do the actual building and monitoring of ontologies. And it has courses. It has the materials from previous ICBO tutorials and from this tutorial itself. So you can go to the website and see what we will be seeing today, and of course come back to this material after. It's an open material, it's a community contributed material, so if you spot a typo, if you have any kind of course pathway lesson that you want to introduce to the community, you can go on GitHub and make a pull request and add this material there. So, and this is incentivized, so please go there and do this because the community relies on this contributions. So today we have 7 different speakers that will address different topics inside the obosphere. First, we have Darren Ateo, who will give us an introduction to obo. Then Sabrina will give us a hands-on lesson, going through a few of the different curatorial steps that people do in the daily life as OBO Foundry participants, let's say. Then Damien will give this very nice update on what Protege has done in the past few months, I guess, and the new features that were released in the new version of Protege, this ontology editor that people use in the OBO Foundry. Then we'll have a break, and Anita will show a bit of the obo dashboard and how quality control is done in obo. Becky Jackson will give an introduction to robots and automation and ontologies. Then Sierra will bring ChatGPT and all these new LLM kind of interactions and how these things are being used or can be used in the obo world. And finally, Nico will give us a talk on open science and how this relates to OBO Foundry. After all of that, we will have a general Q&A and discussion. So we should have some space to ask questions in each of the different sessions, but there will be this general space in the end to discuss about it, right? So you should have access to the website with someone, and without more further ado, let's get started. So I think yeah, there were some more slides, but in the interest of time, maybe we can get started, and perhaps someone can steal the screen for me and all right.
Okay. Hello, everybody, and welcome to this introductory talk on ontologies, and with a particular focus on the open biological and biomedical ontologies. I just want to give a quick shout out to David Osumi Sutherland and James Overton, who gave presentations on this same presentation in previous years, and I've adapted those presentations to this. Also, I want to point out that a lot of the information that I'm presenting here will be found in the online book, the obo-academy O-book. So you can look there for some more information. And we'll get started. First, I asked the question, why do we need ontologies? I could tell you a little story that'll help illustrate this. Once upon a time, many years ago, I had about a 2-hour-long discussion, maybe you might call it a debate, with a colleague over how to interpret a particular set of data. And we went back and forth, back and forth, back and forth. I made my point, she made her point, and neither one of us was giving in. After 2 hours, I finally said, "What do you mean when you say ABC?" And she told me what she meant. And I'm like, when I hear ABC, I think something different. And once we understood what each of us meant, we found, strangely enough, that we were both arguing in favor of the same thing, which I thought was kind of funny. But let's get something a little bit more concrete for you to look at. Let's begin with things that are not ontologies, but that are useful in explaining what makes an ontology an ontology, and what makes an ontology a critical component of information science. We'll start here with something that's called a folksonomy. A folksonomy is useful in helping facilitate searches, just like an ontology does. Basically, what a folksonomy is, there's nothing really organized about it. It's just terms that people use to tag data. It's similar in concept to social media hashtags. When you type in a hashtag, you find things that have been tagged with that particular term or phrase. We have an example of a folksonomy here, NCBI biosample. And you can see there's a whole bunch of terms here, feces, dung, manure, that might mean the same thing. We don't know for sure because none of these will be defined. We don't know what the submitter meant precisely, or even if we think we know, we might be wrong in what we think. So a folksonomy has a few aspects that don't work very well. For one thing, it's a bit too flexible. You can have multiple options that can mean the same thing, and or maybe they don't. There's no real enforcement standards, and sometimes these things are used. A single term could be used to tag data at different granularities, and of course, we can't really tell how each of these terms relate. To fix this, we have this thing called controlled vocabulary. So controlled vocabulary is basically a closed prescribed list of allowable terms. So you have a set of terms, some list of terms. That's the simplest form of a controlled vocabulary, is just a simple list. The terms aren't usually defined, and nor are the relationships between the terms specified, but it helps because it helps solve the too flexible problem. And it does partly address the standardization problem because we're dealing with a standard list of terms. So here we take here's a controlled vocabulary of wines shown on the right: Pinot Noir, red wine, Chardonnay, so on and so forth. And we could use these terms in however we need to use them. But we can do better. We can go and provide a little bit more organization by creating a taxonomy. A taxonomy is basically a controlled vocabulary that has been arranged in a classification hierarchy. So there's an implied relationship between the terms. That implied relation is ISA, or sometimes known as a subclass of. Again, the terms aren't usually defined, but we know a little bit of the relationship between Merlot, for example, and red wine. We know Merlot is a type of red wine. Merlot is a red wine, or Merlot subclass of red wine. These are different ways of saying the same thing, depending on which kind of informatic system you're using. So this helps solve the granularity problem because you have this hierarchy. It partly addresses the term relation problem, and it also provides some additional benefits. One of the benefits is it allows you to be precisely vague. That doesn't make much sense unless you think about it for a moment. Here we show a taxonomy with a controlled, this is a taxonomy of cells. And it allows, having this kind of organization allows annotation at varying levels of precision. So for example, you might want to say something about one of these cell types, and you're not quite sure which cell. You know it's a glial cell, but you don't know which type of glial cell. So what you can do is you can make your annotation to specifically glial cell, and because the ISA hierarchy propagates downwards, anything that you say about glial cell will be pertinent to anything to the children. It's children below in this hierarchy. Another benefit of taxonomy is called multiple inheritance, otherwise known as polyhierarchy. So here, we can start with this controlled vocabulary of wines. And what we notice about these is that they're all different types of either wine color or region or grape varietal. So what we can do is, if we want to create a taxonomy of wines, and we want to use each of these different axes of classification, we can do so. So we can classify, for example, Riesling both as a varietal, which it is, and we could also classify it as a white wine. And this kind of organization is called, this is called multiple inheritance, aka polyhierarchy. Now, despite the benefits of taxonomy, there are some problems that remain. First, terminology alone can be either ambiguous or inconsistent. So here's 5 different photos of actually it's of the same thing. It's the male genitalia of a wasp. Each of these 5 different highlighted areas have been labeled paramere by people studying different hymenopteran lineages. So if somebody were to say, I'm talking about the paramere, looking at this, you can see you don't really know what they're talking about, and that's not good. So that's one of the problems of having a taxonomy. Just for completeness sake, this is what each of these parts are called in an ontology, which provides definitions, references, synonyms, and images, all of which are key to helping users understand the intended meaning of a term. So all of these things are important components that help. These tend to be missing from things like controlled vocabularies and taxonomies. Also, what if you want to classify using different criteria? I mentioned before that a taxonomy is a classification. It's based on is a classification. What if we want to do a classification based on parthood? So, for example, looking at neuron-associated cell, we could say neuron-associated cell is a neural cell, which is part of the nervous system. A cardiac glial cell is part of the heart. And you can skip generations if you'd like and say heart is part of the cardiovascular system. So you could see what happens in a parthood arrangement. If a cardiovascular system has the heart as part of it and cardiac glial cell is part of the heart, then the cardiac glial cell is also part of the cardiovascular system. You could even take these heart and heart plus pericardium out, and everything you say would still be true. Similarly, with the ISA hierarchy, anything you want to say about a glial cell will apply to cardiac glial cell. Anything you say about neuron-associated cell will apply to cardiac glial cell as well. So an ontology puts all of these aspects together. In information science, an ontology is a queryable store of knowledge that represents entities such as objects and events with all of their interdependent properties and relations. So terms are unambiguously defined. Terms are richly annotated, including references, pictures if necessary. Synonyms are really important. You know the relationships between terms. Sometimes it's not just is a or part of. There's a whole slew of relationships that can occur. The terms are usually arranged in a classification hierarchy, just like a taxonomy, usually, but it doesn't need to be. And finally, ontologies are typically expressed in knowledge representation languages, such as RDFS, OBO, or OWL. So benefits of the ontology is everything that I said previously about the benefits of taxonomies and taxonomies and controlled vocabularies, plus it has more. So I mentioned already, terms are defined and the interrelationship between those terms are specified, and this prevents ambiguity. It can be fully standardized, which allows for interoperability. And an ontology, in addition to providing human readable information, also provides machine readable information. And this supports logical inferences and automated classification. And it also allows for sophisticated queries and creation of graphs. I'll talk about the standardization and the machine readable information in the next few slides. So ontologies are generally given in a standardized format. It's OWL2 is what's recommended by the World Wide Web Consortium. It's a formal language for writing ontologies and knowledge bases, for that matter, which allows for automated classification, error checking, especially with respect to consistency, and it allows for the use of transparent query languages, such as Sparkle, for example, after some conversion. OWL is also web native. All the identifiers are IRIs. I'll explain what those are in a few more slides. And you can actually translate between the syntaxes. You can convert from OWL to OBO and other syntaxes. But bear in mind that not all syntaxes are equally expressive. OWL happens to be a pretty good one. The other benefit of standardized format, this is a benefit for any kind of standardization, it allows for a large and growing ecosystem of open source software that works with this format. And it also allows for ontologies and schemas for biology to be expressed nicely. And I'll show you some examples of that in a bit too. So let's talk about the automated classification. I can make a few simple statements. I could say that the nose is a subclass of a sense organ. That is, it's a type of sense organ. The nose is a subclass of anything that's capable of some smell detection. And I can also define olfactory sense organ as being a sense organ that's capable of detecting a smell. What we can conclude from these three statements is that the nose is an olfactory sense organ. What's the reasoning? It's shown pictorially below, but if all sense organs that can detect smells are olfactory sense organs, then the nose, being both a sense organ and something that can detect smells, itself must be an olfactory sense organ. Now, there is software that does this kind of thing, this reasoning. Those are called reasoners. And you will have an example of this, I believe, in the following talk. You can take what I said before, you could take all of this reasoning capability and kind of flip it, right? So here we told you what that a nose becomes an olfactory sense organ after these statements, but you could also ask questions. You could say, what sense organs can detect smells? Well, we have the class of sense organs that are capable of detecting smell. We call that the olfactory sense organ, as I mentioned a moment ago. And we happen to know that the nose is one of these things. And so if you ask what sense organs can detect smells, you'll end up with nose as an answer. We could probably even, if we had the hierarchy here, we could simply say what organ can detect smells. And we can use the hierarchy in this way and still come up with the same answer. So this is one of the many benefits of an ontology. Another benefit of ontology is hierarchical query expansion. So what does that mean? That means you can use the nature of the hierarchy. You recall what I said earlier, that anything that applies to a glial cell also applies to macroglial cell and microglial cell. If you were to ask what genes have been annotated in mouse glial cells, if you did not have a hierarchy, the answer would be 23 for glial cell. Without the hierarchy, microglial cell 92 and macroglial cell 92 and microglial cell 60. So if you do the query for glial cell without considering the hierarchy, the result you'll get is 23. But if you add any of the genes that have been annotated to something more specific than glial cell, then you get the result of 158 if you can consider the hierarchy. So again, that's a lot more complete. And this is the sort of thing I think Google does something like this, if I'm not mistaken. They use these hierarchies to help fill out the information you want. Another benefit of an ontology is managing multiple inheritance. So I mentioned before, you can have multiple inheritance with ontologies. And these can be difficult to deal with if you're doing things manually. So first of all, it doesn't really scale very well. If you're adding a new class, a human will have to know where in the hierarchy it fits. Are there any rearrangements that need to be made? And if all the classifications are appropriately added. That's a difficult thing to do when you have manual maintenance of multiple inheritance. It's also bad for consistency. Sometimes you don't really know, just looking at a classification, what the reason for these are. And it's sometimes hard to check for consistency with when you deal with distant superclasses. By superclass, I'm talking about things like parent terms or grandparent terms or even great-grandparent terms and beyond. And also, it doesn't allow for querying so easily. Manual classifications can't be queried for classes with arbitrary sets of properties. So the bottom line for this is a best practice that we would say is automate what you can. So leverage the ability of the ontology to do this automation. In fact, here's an example of an ontology that has been fully automated. It's 100% reasoner driven. The ontology itself will look like, if you just look at it, it's going to look like just a simple list. But once you throw a reasoner over that, you'll discover, oh, there is some hierarchy here, and the hierarchy will be viewable. And again, you'll see examples of this in a later talk. So now that the basics of an ontology have been covered, how do you go about using and reusing ontology terms? Well, we've actually already seen this in a sense. I referred before to olfactory sense organ and sense organ. These both came from an ontology called Uberon, which is an anatomy ontology. The capable of is a relation that comes from the relation ontology, and detection of smell comes from the gene ontology. So we've already seen how you can combine different ontologies to make statements that make sense to you or to make term definitions. Here's a really nice example using the ontology of biomedical investigations. This ontology consists not only of its own native terms, but also terms from the environment ontology, infectious disease ontology, the aforementioned Uberon, the chemical entities of biological interest, the cell ontology, gene ontology, vaccine ontology, the information artifact ontology, the core ontology for biology and biomedicine, and the basic formal ontology. And I didn't even show all of them. There are others that are included in OB. So this illustrates another best practice: leverage the work that's already been done. And by the way, doing this avoids the pitfall of folksonomies. You can imagine if you had, 4 different chemistry-related ontologies with all different terms that mean the same thing, that makes things difficult to interoperate. But by having single converging ontologies, it helps to make things very clean, clear, and standardized. Before I get into the specifics about the OBO ontologies, the OBO Foundry, I want to just go over a little bit on identifiers. So a group of ontologies, which are loosely coordinated through the OBO Foundry, have standardized their IRIs using what are called PURLs. So a PURL stands for persistent URL. That's a URL that's used to point to a specific resource, even if that resource moves. So, for example, I work for the protein information resource. Our website used to be located at pir.georgetown.edu. If I had a document located at pir.georgetown.edu, I would have to change all of my links, and everybody else would have to change all of their links when we moved that website to proteininformationresource.org. That's a lot of work. A PURL prevents that sort of issue. PURL will allow you to say, you have this one PURL, let's say pir.org, PURL.pir.org, let's say, and I could say that this PURL in the past pointed to pir.georgetown.edu, but now it points to proteininformationresource.org. Similar thing happens with ontologies. Here is a PURL that points to the entire cell ontology. And here is a PURL that points to a specific term in the ontology. And just for completeness, let's go through the rest of this. URL is a uniform resource locator. This is a web resolvable URI. A URI stands for Unique Resource Identifier. And this is just basically something that unambiguously identifies a particular web resource. And then the IRI is an internationalized version of that, which is a URI that can use characters in multiple languages. So you'll notice that these pearls are somewhat non-meaningful, with the exception of perhaps this little part right here, CL, which stands for the cell ontology. If you ever need to change the name of your terms, you want identifiers that will stay the same even if the term name changes. So this is the same kind of thing that that I just explained about pearls and websites. So one might imagine that sometime in the past, a microglial cell was simply called Ortega cell, and maybe there was a Wikipedia entry for Ortega cell. Well, that then changed to microglial cell. So the pointer to this, what Wikipedia uses the names of their page as their URL, and when it changes, you have to change that any references to that. So here I see microglial cell has this unique identifier, which is perl.obolibrary.org/obo/cl_000129. So that's the microglial cell. And that's specific for microglial cell. This doesn't apply to anything other than this. So there's a one-to-one correspondence. Now there is a shorthand way of saying all of this. That's called a query, compact URI, and it has the form CL:, and then what this part is called the local identifier. So all of this stands for this. In particular, you can define these prefixes. The CL can be defined as meaning everything from starting from HTTP up until CL_, and then you have the local identifier. So that's what a query is. You'll sometimes see this used. When you see this, it is meant to be understood to be, at least for this case, meant to mean this. Now, how do you go about finding the right ontology for your purposes? Well, there's some resources you could look at. One resource, this is the one I'm talking about, and we'll be talking about for the rest of the day, is the OBO Foundry. There's also ontology, which has over 200 OBO Foundry ontologies and other ontologies, similar to the ontology lookup service. And but the biggest one that I'm aware of anyway that you can find ontologies is called BioPortal. It has over 1,000 ontologies last time I looked at it, which was earlier this week. By the way, if you have copies of the slide, all of these are linked. When looking for an ontology, there's a few things you want to look for. You want to be aware of its license. Are you free to use it? And if you use it, can you share your work? There are some licenses that do not allow you to share your work if you use the resource that has a restrictive license. You want to look at its quality. Is it scientifically sound? And is it interoperable with other ontologies? And finally, you want to know, is it being actively developed? Can you contribute fixes? Can you ask questions? Things like that. And this actually forms a pretty nice segue into the main topic for today, which is the OBO Foundry ontologies, OBO. Here's a quick overview. I'll be going over these particular points in subsequent slides. So OBO is a community of more than 200 open scientific ontology projects, and it's growing quite a bit, actually. We get requests for new ontologies pretty regularly. It covers multiple areas, so there are ontologies in all kinds of areas of expertise. There's been a long history of cooperative development for these ontologies and for the tools. Each ontology follows a prescribed set of principles and best practices for integration and harmonization. And they've also developed a number of community tools and infrastructure. On this slide is a bunch of prefixes for a whole bunch of OBO Foundry ontologies. I won't go over this, but this is the prefix list that's on the OBO Foundry list of active ontologies. One of the nice things about the OBO Foundry is it does tag ontologies with their status. Some ontologies become inactive, they're no longer developed, and we tag that. We make sure that the user is aware of this, because that's useful information. Here's the kind of the grand areas of coverage. All types of biology, chemistry, medicine, even information and information technology, and simulations. And then all of these are brought together under the umbrella of some upper ontologies, a couple of which I've already mentioned: BFO, the basic formal ontology, COB, and also the relations ontology. Here's the history of the OBO Foundry. It basically started when 3 model organism databases, Flybase, Mouse Genome Informatics, and Saccharomyces Genome Database, got together and created the gene ontology. That was back in 1998. The early history of the OBO Foundry was mostly focused on bringing together different ontologies, doing outreach. So we have, the OBO Foundry was established basically it's 20 years ago. 20 years ago, I think in May. And there's been, various publications about it: the Relations Ontology paper, OBO Foundry paper. The series for which this obo-academy is part of, ICBO, was established in 2009. And then 2015 and subsequent years has really been devoted toward tooling systems. There was the development of Robot. You'll hear about that later on today. The Ontology Development Kit, the OBO Registry. So this is where people, you can see the results of the OBO Registry on the website, and the OBO Perl system, which I spoke of earlier. In 2019, the OBO Dashboard was developed. The OBO Dashboard is a quality control tool. 2021, obo-academy, you're listening to that right now. And then in 2022, we revamped the website. So now we come to the part about OBO principles. I won't go into these in any kind of great detail, but I'll point out a few of them that are really important. One is the first principle and the second principle, open license and the common format. This allows for A, interoperability, and B, reuse. Helping standardization, we have the third principle, the URI/identifier space. We also require that ontologies keep past versions, so that if you worked with an ontology from 2010 and you need to go back and take a look at that, you can do that. So all OBO Foundry ontologies have a retrievable history. Each OBO Foundry ontology has a prescribed scope. So there's a specified area that it addresses. So KEBI, for example, addresses chemicals. Protein ontology addresses proteins. And you don't go beyond these areas. You're supposed to, if you have need for a term that's in an area outside of your ontology, you simply ask the developers of the ontology that should house that term to add it. The sixth principle and the eighth principle, this is about text definitions and documentation. That helps humans understand what's going on. Relations, again, I spoke about this from the relations ontology. This helps interoperability. The ninth principle is documented plurality of users. This means that you know that people are using your ontology. And if people are using your ontology, that means it's useful. So we want the ontologies to be useful. So they're developed in a way so that people will use them. We're all about collaboration, all about collaboration. come to that in a bit more. Every ontology should have a contact person. There should be a person you can call, not call necessarily, but email, let's say, for anything you might need regarding that ontology, any questions, how to contribute, things like that. We follow a particular set of naming conventions. So, for example, naming conventions, this refers to always using, for example, lowercase, unless you're dealing with, names of something. A relatively new principle is Principle 13, notification. This alerts users to major changes. Again, this is important because you don't want people to try and rush to get to what you're, to keep up with anything that you've changed. The 16th principle, maintenance. If there's new information that comes out about something, you want to make sure that the ontology reflects that new information and deletes the old, not deletes it, but obsoletes the old. We track everything, by the way. And then finally, the last one is responsiveness. So if a user has a request to make, you have to respond to that. And so all of these things are basically different ways of collaborating, of making sure things are usable and interoperable. As mentioned before, the OBO Foundry has developed a number of tools and aids for best practices. There's the OBO registry, which holds the metadata for the ontologies, the identifier system, the pearls. Robot is an ontology development automation tool, and you can automate workflows using the ontology development kit. These things will be talked about in later talks. The OBO dashboard is the quality control part. And by the way, some of these things, with the exception of the OBO registry and the OBO Pearl system, those two do require that you're part of the OBO Foundry to use, but all the others are available to anybody. And then finally, we have this obo-academy that we're for documentation and training. All right, so now that you know about the OBO community, how do you participate? Well, here's one thing. First, before I get into that participation part, let me point out a little bit of how the OBO Foundry is structured. Day-to-day operations of the Foundry are handled by the OBO Operations Committee. We have regular conference calls where we discuss issues. There's the 3 working groups, the editorial working group, which takes care of any kind of the writing aspects on the website or any documentation that's needed. The technical working group, these guys are the real workhorses here, the ones who have developed all of these tools and maintain the website. And then the outreach working group you're listening to right now. How to contribute? Well, there's a number of ways. First, any questions you have, you can go to the OBO Discuss mailing list. The link is there. You can use the OBO Community Slack channel. There's also the GitHub issue tracker. You'll learn about this also in a subsequent talk. And then the newest thing that we've got is this OBO newsletter. So you can read about the goings on at the OBO Foundry. So in short, I just want to say that the OBO Foundry, we offer a lot of guidance to help develop and maintain your ontology. So you're all welcome to join us. And with that, that's my last slide.
Yeah, thank you, Darren. Great introduction. We are a bit late, but if anyone has questions here or in the chat, maybe 1 or 2 questions. And does anyone have a question? No.
Looks like it. Let's see. Nico?
There's one question here, Darren, but just a second.
Hello, I'm Jose. The camera is over there. No, I don't know. Depends on here. I can see my back. This one. Okay, I'm Jose. I have worked with the BFO and I have some contact with OBO. And I saw the list about of the areas used, and my question is it possible to include new areas? For instance, the aeronautics area, the aeronautic information. I work with this area, and we have developed some terms for instance, meteorological terms, air traffic control, and we need a standardization of these terms for general use. So my question is about the possibility of including new area. Okay.
Absolutely. The areas that I showed, that's basically a bottom-up list. So if you take all of the ontologies that we currently have and figure out what areas they are, this was the list that we got. There was a time where we had no simulations. There were times where we didn't have, some of these other areas covered at all. But as the ontology repertoire grew, so did the areas. So yeah, absolutely, we positively can add. And Nico points out we also have environmental ontologies.
Sure. Yeah, I think. Yeah, he said. Yeah, I think we can go to the next speaker. I think it's Sabrina. But thank you, Darren. Yeah.
Thank you.
Thank you, Darren, for setting up the stage for me and everyone. And hi, everyone. It's very exciting to be here. This session will be really much like a working session. So if your laptop is not on, please turn it on. We are going to talk about basic tools for ontology. So this session will be very basic. So for some of you, it might be very simple, but if you're just starting with ontology, this is the 101, like what you need to know about ontologies. We are going to follow all the work that is already shared in the obo-academy. So if you go to the obo-academy, you have much more details about every single thing I'm going to say today. I am putting in the chat also link to our website. This is basically an easy place to find all the links that you will need today. So today or going forward. So if you lose that page, don't worry. You can still find it on the obo-academy website by just a quick search. So what we're going to do today is clone a repository. So how do you get an ontology on your machine, an ontology that already exists on your machine, how you can browse it using Protege, and then we'll look at how we can make changes in the ontology and how we can participate in ontology work. One thing that you need to have in order to be able to follow along is having Protege install and having the GitHub desktop install. All the links are on the website and on the page that I shared. So hopefully you already have that. So let's get started. Also, as I mentioned, we are doing that, like you should be able to follow me and do things as I go. I have a new computer, so everything I'm doing with you, I'm doing at the same time. So in theory, you should all be able to follow up. If there's any questions or if there's something you don't understand or you need more time, please raise your hand or talk either here on Zoom or over here on in Brazil. Just interrupt and let's all work together. All right, so GitHub is really the place where you want to have all your ontologies, and all of them are available in GitHub. So all the OBO ontology would be found in GitHub, and all of them really looks the same. I'm going to put a link in the chat. This is the one that I am using today. This is the one I work on. So this is the one I know the best, but basically they're all the same. They all have a GitHub repository. And before we do anything, let's get this GitHub repository and let's make a copy on our machine. And then I'll tell you a little bit more about this while we get going. So get to a GitHub repository. This is where you arrived here, code, you click on it, and then you have clone. The easiest way to do it is open in the GitHub desktop, open GitHub desktop, and then you have options here. Do you want to clone your repository? This is what do you want to put it here? It's usually going to put it in your document on your machine and in a folder called GitHub. So I am fine with that. Click clone, and that can take a few minutes. So while this is happening, let's put that on the side. Let's talk about what is happening here in the GitHub. So the GitHub repository basically contains everything that is related to an ontology. It contains the ontology, which is what we're going to focus on today, but it also contains everything you need in order to work on the ontology and create release of the ontology. It contains the documents. So the repository is basically everything about the ontology and everything you need for your ontology. This is going. So you can see here we have different tabs. The tab that is of very high importance for all of us is this one, the issues. Issues here is basically the work to be done, or questions, or anything that you would want to share with the team that is responsible for this ontology. So here, for example, somebody created an issue and said, I would like to add those cross-reference from this resource. There's another one somewhere that says, oh, we need to update those documents. So this is the first step in the first place where you can participate in ontologies. It's by coming here and creating issues. So if you see something that is weird in the ontology, you find a term that has a typo, you find a term that should be classified somewhere else, you come here on your ontology. Let me move some things around here. You come here in the repository issue, and you click here, new issue. You are coming to a different page. All ontologies have different pages. When you create a new issues for this particular repository, we have different ways of reporting. If we want to add a synonym, if we want to fix something. But here at the end, you always have the ability to add a blank issue, and you can just click here, add a title, explain what your problem is or what you have found that needs attention, and then submit a new issue. Of course, it took literally 2 minutes last time when I did this, and now it's going to take its sweet time. That's okay. So there's also a tutorial and documentation about how to create new issues and how to create issues in the obo-academy. And when you create an issue, you need to be as specific as possible, because otherwise you're going to have a lot of back and forth, and it's going to take longer. One reason to use GitHub is that it's open. So anybody can just come here to any issues and then follow the discussions that we're having. So this is not a good example, but anybody should be able to come here and then see the discussions that everybody has had about this particular issue. you are able to just come there and then add your comments if this is something that you have, or if you want to add and participate in the discussions. So all of these, this is taking, sorry, I swear I planned and I practiced and it was taking less time. All of GitHub is the place where you can get all your ontologies, and it is also the place where you can interact with everybody who is working on the ontologies. All right, this is still being cloned. And it's going slower, so let's just move on with something different. So on your machine, GitHub is cloning the repository. It's going slow for Mondo, but you can see that in your document, you're going to have Mondo, you're going to have a GitHub, and then you're going to have a folder for each ontology that that you have cloned on your machine. So what we do, it's basically we go on GitHub, we clone, we copy the ontology. Now it is on our machine. And if we go on GitHub desktop, that is going on, we'll talk about that later. Okay, so now let's open Protege. We cannot open Mondo because it is still being cloned, but I have another ontology. So let's start looking around Protege for now. So when you open Protege, you arrived at this semi-random page that is basically an opening page. And so we want to open the ontology that we want. So here we go on File, Open. If you want to open from a URL, you can do that. But because what we want to do is look at the ontology and potentially make changes, then we want to open it from our machine. One thing I'm going to show here also is that you always have the open reason, which is very useful when you have the same ontology that you're opening again and again. So we will open. We will find on our machine where this ontology is. So we are here in Document, GitHub. Let's open this other one while the Mondo is still being cloned. And the ontologies that we want to open are always in the source folder. So we go on source, ontology, and then you will find your VBO edit.l. Sometimes for Mondo, it would be Mondo Mondo edit.obo. This changes depending on your ontology, but the one that you want to open is the one that is in this ontology folder. Okay, let's open this. Yes, you can have access to this. And so Damien is going to talk about all the new things that are the new options that are currently in Protege. One of these are ID range. He's going to talk about it later, so I am just going to ignore it. So here we are in Protege. There's some preferences to be updated and set up if what you're going to do is create new terms. So we are not going to talk about that today. We're going very simple, so we're not going to talk about adding new terms, but please keep in mind that this is and you have an additional step if you want to add new terms, like for example, you need to have a range of ID so that you can have ID for your term that you created, but we're not going to go there today. So when you come to Protege, here you are. This is your front page with some information about the ontology, some metrics here, some information here about ontologies that you're importing, like a component from your ontologies, this sort of things. We are going to kind of ignore that today, and we're going to focus on this tab, entity. So entity tab is really where you're going to find all your terms. Okay, this is where you're going to find all your terms. If you open here on this side of the screen is the class hierarchy. You can see that here it is a class hierarchy of very, very high level, and the way this ontology is created, you have a lot of classification down. So the easiest way to find something is this button here, search, and then you can type whatever you want. So you can see that while you start typing, you have a lot of options coming in your search. If, let's say, we wanted to look at, so we're looking at an ontology of breeds here. So some of the names might not be obvious to you, but until Mondo is hurrying, this is what we have. So you can see that as I type, options are coming here in the search results. I can start big and enough words and not full words. So if I say ngo cat, then you can see that it will search for the whole term that has the part ngo and cat. You can see here that the search will give you will give you options for anywhere it has found what the query that I added. So here started with a display name, so the label, looking at other places, other display name, label, also subclass of. So it's going to look everywhere in the whole ontology and find what I was searching for. You have an option to add case sensitive if this is something that is useful to you. I personally have never had the need to use this. Another thing that is very useful is here, click show all results. Sometimes it's helpful, sometimes it is not, but just know that this is an option, and it is good to use it. Okay, let's go to a term. We just clicked on it. Here we are. And now we have Mondo that is ready. So let's open Mondo in the background. Do I want to? Nope. Open Mondo. So source ontology, Mondo edit.obo. And then now we can look at names that are more familiar to all of you. So looking at how, same thing here. Okay. So looking at how chromosome 30. Looking I am looking for brain chromosome 13. Here it is. Okay, now we're on track. So looking at Protege here, we have the hierarchy. Let's not pay too much attention to that right now. But let's look at those different areas in Protege. Here we have the annotations, terms annotations, terms description here in the bottom. In the term annotations, you have all the annotations related to the term. So we have the ID, we have the label, we have the definitions for the term. As Darren explained earlier, definitions are very important. We also have other information like synonyms. We have different type of synonyms. We have synonyms that are exact, we have synonyms that are related. We also have cross-reference databases. And so anything that is associated with the term and anything that can help with disambiguating the term and defining the term will be here. And it's not completely correct, but let's roll with it for a second. So this part here, that is here, the annotations are not going to be passed to the children. So these are everything that is true for that term, but not necessarily for the children of that term. If you look at every annotations, there's some lines in between. They have a very specific, let's call it title for a second, like definitions. See also, this is called an annotation property, and the annotation properties can be found here in that tab here. And these are all the annotations that you can use to attach to your term. So for example, here you have database cross-reference. We have also definition somewhere here. And all of these comes from other ontologies and other terminologies and have been accepted by the whole OBO community. Some of them have been accepted by the OBO community. Some of them are very specific to your ontology. So keep that in mind. And then some of them have also annotations on their own. So for example, your definition has a cross-reference that tells you what the definition comes from. If you look here, the little yellow, the @ symbols, and you click on this, this is going to open the annotations for this particular annotation. So here we can see that we have a database cross-reference that is orphanet number, blah, blah, blah. Okay. You can find on the obo-academy a longer talk and course about those annotation properties and how you use them and how you create a new one. So we're not going to go there today because of time, but just know that that tutorial exists. Now, like Darren told you earlier, he talked about subclass of and logical definition, where we can say in this case that this disease, ring chromosome 13, can be defined as a ring chromosome disorder, and we're saying this has some alteration in the chromosome 13. Here we have, so here, this is a definition, the logical definition. Here is the subclass of, and this is where you add all the parentage. So for example, if you don't see anything, it means that is a. So here we say that this disease is a syndromic anorectal malformation. We could say also, like, if you remember the example of the neural cell is part of the nervous system, you would have it here too. You would have part of nervous system. So these are what is going to be passed to the children, but this is also what will define, what will help with the auto-classification. And this is the role of the reasoner that Darren told you about earlier. So if you go here on reasoner, start reasoner, and you can see this different one here. Let's just start it because it sometimes takes time and everything is taking much longer today. So you can see that we have different reasoners options here. The one we use for the biomedical ontologies is ELK. There's a lot of documentations about that. Very, very shortly and very high level, those reasoners basically look at all those axioms. And sometimes some axioms are very specific and very precise. So they're all precise, that's a word to use. But sometimes you have things like that the axiom refers to a very specific value. So the reasoner will have to do more computation in order to figure out what auto-classification exists. By using ELK, we are basically saying we don't need those very specific classification using those very particular auto-classification and axiom based on numbers, because we don't use that for the most part in the ontology. So for those ontology, the ELK reasoner is really the best for what we're doing because it doesn't take very long and it works. Okay, so when I did that, you can see there's some things in yellow that appear, and it's basically new subclass of. So the reasoner looked at this and decided that, oh, then based on this definition and based on the other things that we have in the ontology, this disease is also a chromosome 13 disorder and is also a ring chromosome disorder. So now let's look at this hierarchy. Darren told you earlier that there are some ontologies that are really flat, and you need to get the ontology, the reasoner running in order to see the classification. The way we do that is here, we have assert it, click on it, infer, and then now you have your ontology that is, you can see the hierarchy of your terms that that has been auto-classified using the reasoner. Every time you look at an ontology on your own, every time you want to make a change or look at parentage, it is very important that you look at the ontology in the inferred view, because this is the only way that you can make sure that you're seeing all the parents of every term that you have here. Okay, so here, as I mentioned, we have new parents. One thing that, maybe here it might be obvious, but maybe you're just wondering, like, why is this becoming a parent? Then you have this little question mark. If you click on it, sometimes it goes for very long, sometimes not. But clicking on this question mark will basically look at the reasoner and send you explanation of why this parent, this inferred parent is given. And here it basically saying, because ring chromosome disorder is a chromosomal disorder, and because of your definition here. So anyways, you can have answer to those questions. And every time you will see, you will get some new parents or some new axiom that you didn't realize that you didn't expect to have. And in some cases, they're correct. Thank you, reasoner. We have a better classification. Sometimes it's obviously not correct. If it is the case, it means that you have done something wrong with one of your logical definitions, or you have done something incorrect with the classification that you have manually added. So this question mark and this reasoner is extremely useful. Okay, here, same thing, now that I see it, I didn't mention it. We have the subclass of all this axiom that you asserted, that you wrote manually, you can also add annotations to them. Here, if we click on the little @ we can see that we added that the source for this axiom comes from this cross-reference. Let me see. Oh, one more things. Here we have some relations that disease arises from alteration in structure. If you click on this one, you should be able to open it, and you can see that all of those relations are in this tab, object properties. And like any terms, you have a label, you have a definitions, you have a database cross-reference. If you remember how relations work in an ontology, so you have some properties of whether the relation can be transitive, symmetric, you can have ranges. So all of that is in here in this object property tab. So when you start working with ontologies, these are really the three tabs that you will use. Okay, how are we doing on time? And let's take a short check to see if everybody is following or if there's any questions, either on the Zoom or in person.
Sure. So there is some issue of discussion because the coffee break is there now, but as we got delayed, but just a second, I'm gonna verify.
Okay, is there any other question that is not related to coffee? Because
Hi, Sabrina. Yeah, I have one.
hey, yes, go ahead.
So it looks like if we go up into can you go up to like the more root terms here? Maybe like one level under thing.
One level understand the thing.
Yep.
That's a very high level.
So I noticed like different ontologies implement like these kind of base entities under thing differently. Is there like a standard way or a standard format that we should be starting these if we want to make our own ontology? Is there like a template somewhere maybe?
Yes, and please, anybody correct me if I talk wrong. So here, what is underneath things is usually one of those upper ontologies. It could be BFO or COB. And these high level ontologies will give you that high level basically classification, and everything we put underneath it will be part of this high level. So if you create a new ontology, it is always a good idea to use an upper ontology that other people use also, because then you can bridge those ontologies together. There was something else I was going to say, but yeah. Nico, is that would you? Okay,
I would.
great answer. Yeah.
Your answer is totally fine, and I think it's a bit of a shame that there's not a one canonical answer to this question. I would say looking at COB and how COB is classifying top level is probably the right way to figure out where those upper level classifications go into. But yeah, right now there's no standard way across OBO that everyone agrees on how to organize the upper level when you start a new ontology.
Thank you.
All right, I see you will need a break in 10 minutes. So let me give you a 10-minute quick how to make a change in an ontology, and then it's going to be quick. We can come back to it later. You can look at the documents that we already have online. But okay, so this is how ontology editing looks like. So we talked about the OBO, the GitHub.
Do you wanna? Yeah, it's a super quick question.
Hi, how are you? My name is.
Hi.
I'm following along. Everything is fantastic. Thank you so much for your time. I have a quick question regarding the inferred tree. You recommended to switch to the inferred to be able to view what the parent terms are. However, when I click the inferred, my tree appears empty. So I'm not quite sure if I'm missing a step.
Okay. Did you go on Reasoner and start Reasoner?
Let me, 1 second, I'm going to bring my computer.
Yeah. So here you can move back and forth. Let's go back to the other ontology that I have opened. Here I can go to the inferred and I'm not going to see anything. And the problem is that I'm asking it to show me the inferred tree, but I haven't started the reasoner. So it says, this is what I have, but I didn't give him anything or give it anything to do. So go to your ontology here, open in Protege, click reasoner. And this one here is already grayed out, but here, let's go to this one, reasoner. And then the first thing is start reasoner. And then click on this. And then, well, I can actually do it here. And then by doing this, I should be able to now see all of my ontology. Did it solve the problem? I don't have the visual, but I'm assuming that you had to run back and forth.
Yeah, sure.
Diego, did it solve the problem?
No, you can continue. It's okay. Yeah, it works.
Okay, perfect. Any other question?
Not from here.
All right. Okay, so it's going to be quick. I'm going to go very quick, but we can do it. So if I want to do a change in the ontology, what I do is copying the repository, which is what we have done. And what we see in GitHub and what is called master is basically the latest version of the ontology. So everybody will come and make changes. And then we say, yes, those changes are good. We're changing the ontology. The master is the latest version of the ontology. And then over time, we will decide, okay, we are ready for the world to see this master, and we're ready for this to be a new version of the ontology. And so we will have a release. So, what we do is we're going to take master. We have a copy on our machine. We're going to create a branch. And I'll show you in a second how to create a branch. This branch is basically your little part, like you make the copy, you're going to make changes on your side, do whatever you want. And then you're going to create a pull request to say, hey, I'm ready for everybody to look at my changes. Somebody will review it. If we agree with the changes, those changes will be added to master, and then master will now have your changes. If we think there's more to do, then changes will be asked. And there's going to be a lot of discussions. This can go for a long time and make discussions and then push. So the way to do that, and if this is going too fast, let's go back later to this recording. So we have an issue here. It's in Mondo issue number 6596, and I'm saying you need to do some term renaming because there's a problem, other things, blah, blah, blah. So I go to my GitHub desktop. Here I know that I am in Mondo. As we see this, all your repository will be there. So I am in Mondo here. And I want to create a new branch. So I will say my branch will be called issue number 6596. We can talk about how you name your branch. Every ontology and every group have their own way of naming branches. So let's not go there now. And then new branch. Do you want to create a branch? Yes, create a branch. So what we have done now, we are on this part of our pipeline. You cannot do anything wrong. I say that all the time because I was really afraid to do something wrong. And what if I break the whole thing? You cannot change, you cannot break it. So let's open our Mondo edit. Do I want to nope, give me another window. And then, of course, this is going to take a little bit longer. We're going to make a very simple change. And if you go here, we can put a link in. This is like different changes that you might have to do in an ontology. But okay, so we want to change the name of this term. So we are here in Mondo. I don't need to see that right now. Let's find this term. Yes, this is the term I want. And this is all we have seen before in Protege. If you want to do a change, all those changes, you can click on this little round circle. It's going to open the edit. If you click on the X, it will remove it. We don't want to do that. We just want to open it, and we're going to edit this term, label, okay. We're going to save. It is saving. Sometimes it takes some time. And then now we're going to go back to the GitHub desktop. So here we can see the changes that we have done. And then we see that in red is what I've removed. In green, this is what I added. And you can decide if you want to have everything on one line or the split view. This is up to you. Now we're going to push this into a PR. So we're going to share with the team. This is the changes that I made. Here you add a title, be as specific as you can. So updated label for this term. We can say whatever we want, a description. If we want to refer as much as possible, refer to the original GitHub issue, because this is really helping. Commit to issue, publish branch, blah, 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 blah. So, and then preview, create pull request. So here is basically your pull request. You can create pull request. What it will do, it will basically will be here. Somebody on the team will come and review it. If the review is correct, they will say, that sounds good, and they will merge it. If something needs to be updated, then they will say, please change these things, and we don't have time to do this later. When you push the pull request, there are some checks that are happening. So if you did something really bad, the checks are going to fail, and we're not going to push it to master. If you forgot to create a branch, when you are pushing, you can still say, oh, by the way, you know, do you want to create a new branch, or do you want to push to master? No matter what you do, nobody will be able to break master, because there's so many checks in place. So now let's say you want to work on a different issue, and I'm sorry, I'm very fast, we have 1 minute. You would come here on GitHub desktop, get master, fetch origin. So what you're saying here is, give me the latest version of master. So you're starting again with what the ontology is, and then here you are again. You can create a new branch and go forward. So it's this part is very, very quick. There's more recording. So join the obo-academy if you want to go deeper into that. And I'm very sorry I went over, but basically play around, like look at your ontology on Protege. This is really the only way you can be comfortable, and just don't be afraid. Nothing can be broken. There's checks in place. The changes can be discarded or added. You can start fresh. If you don't know what you're doing, go back to master and start again. Also be part of the community. So be involved with, look at GitHub, make comments on GitHub, participate in the discussions. If you want to create a PR on somebody else's repository, it's fine. Just do it. And the worst case scenario is that the other people don't agree with what you said. The people in charge of the repository don't agree with with your PR, and they're not going to merge it. So yes, I am between you and your coffee. If you have any questions, please join the OBO Academy. Contact us on Slack